VPCs, subnets, internet gateways, and NAT gateways. In this episode, we'll look at a practical example of how to set them up. So instead of talking theoretically about what is a VPC, what is internet gateway, what is not, we'll discuss it, but we are going to focus on the practical part. So to create a VPC, a virtual private network, then basically you go to the AWS console if you want to do it in the manual steps, and it's recommended first to do it in the manual steps so that we can see clearly what are the components and what we are doing, and then when we feel comfortable, then to do it with the scripts. But so to create a VPC, which is the container, which is the whole network that we are using, we go to the AWS console. We would already see that we have there a default VPC that AWS has created for us. So instead of creating a new one, we can just rename it and give it our name. And when we create it or rename it or use it, or let's say that we create a new one, then it would ask us to enter a CIDR block. So the whole point of CIDR block is to let AWS know what is the range of IPs that we are going to use. We are creating network, right? We are we're going later on to split the network to subnets. So obviously we need to tell AWS what is the IP range of such a network. What is the IP range of the VPC? What is the IP range of the subnet? And in order in networking to say what is the range of IPs, we use a CIDR. CIDR is just an IP with a slash and then a number. So in this example, we are going to create a VPC with a CIDR range of 10.0.0.0/26. What does it mean? It means that our IP range will start at 10.0.0.0.0, and the number of IPs that we're going to have is /26, but not exactly /26. It's going to be 2 to the power of 32 minus 26, which is 2 to the power of 6, because 32 minus 26 is 6, and 2 to the power of 6 is 64. So we're going to have 64 IPs in our range. And the reason is that it's /26 and not /6 is because the number that comes after the slash is the number number of bits that are denoting what is our network. So if the number of bits is 26, then 32 minus 26, which is 6, is the number of bits that are going to denote what is our actual IP range, how many machines we can have. So created the VPC, and now let's move to the next step. Next step will be subnets, and then we would create the gateway, internet gateway, and then the NAT gateway, and let's continue. So to create a subnet, now we are going to say, okay, so some of my network is private and some of my network is public. So we can create a subnet and actually choose in the combo box that it's private. We give it a name, and then again, because it's a subnet, we need to give it what is the IP range. So now we would say, okay, in the VPC, we gave the IP range of 10.0.0.0/26. So let's start from the IP 10.0.0.0, because this is the starting IPs, but we're going to have less IPs in the IP range, so /28. So more bits to the network. Then let's create another subnet. If the previous one was public, let's create a private, and we just choose in the combo box private or public. One of them would be public and one private. And then again, we say, okay, the IP range now, okay, so we used already 16 IPs, so 10.0.0.0.16 this time, not .0, because this is the second subnet. It would start with an offset /28 again, because we're going to have only 16 IP addresses in this one. Basically, after we create a subnet, we would see that AWS would tell us that we have only 11 available IPs and not 16 as we expected, because 5 are going to be used for internal usage in AWS. Next thing to do is to create a route table. Basically, we just click add a route table. One again would be private and one would be public. And later on, we're going to use this route table. The important thing in this step is just to assign the subnets to a route table. So each subnet would have its own route table, but each route table can have multiple subnets. And we can actually, now we want to update one of the route tables to be public and one of them to be private. We don't have a combo box to choose if it's public or private. The way we do this is by assigning the internet gateway, which would allow traffic from the internet to come to us. So create a new internet gateway. This would allow traffic from the internet to arrive to us. And then we click the route table that we decided that it would be the public route table. And then we add the address 0.0.0.0 to internet gateway. So we're saying traffic from the internet can come to the internet gateway. Then we're going to add NAT gateway. What is the difference between NAT gateway and internet gateway? Internet gateway is what brings traffic, what allows traffic from the internet to arrive to us. And NAT gateway is what allows when our server in a private subnet, in private, is going to access the internet, then we want the reply to get back. So let's say that we have a server that downloads patches from the internet. Okay, so it's downloading the patches, but now this server is private. We want the patches to actually arrive to us. NAT will allow the replies to access us and not just the global internet access us. So this is a security on top of the private. Basically, the same thing as an internet gateway, only in this time, it's going to allow only replies to come to us from the internet. So we add a NAT gateway, we place the NAT gateway in a public subnet. So when we add the NAT gateway, we need to put it in a public subnet. But hey, you said, but you don't allow all the traffic from the internet to arrive to us. Yes, but the NAT itself is exposed to the internet. So it needs to be in the public subnet. So NAT gateway lives in the public subnet, but it's serving private subnets. And then we would go and edit the private route table. This is the way we connect the subnet to the NAT gateway through the route table. Okay, so we go to the route table and to the private route table that we had, and then we edit, and then we add there an entry of 0.0.0.0 to the NAT gateway that we have built. This was a brief overview of actually how to create VPCs, subnets, internet gateways, NAT gateways, and route tables.